Suppose you want to test the null hypothesis that the mean value of sales after an advertising campaign is 10 against the alternative that it is less than 10. So the null hypothesis is that mu equals 10 against the alternative that mu is less than 10. Assume that you know that the standard deviation of the value of sales is 12. So sigma is 12. You decide that you reject the null if the average sales in 16 stores are less than 8. So we got 16 stores, so n is equal to 16, and we reject h0 if y bar is less than 8. And we need to calculate the size of our test. Now, size of a test is the probability of rejecting h0 given that h0 is true. Now in our case, we set up the decision rule that we reject h0 when y bar is less than 8. So we need to find the probability that y bar is less than 8, given that the true mean is 10. So what is the probability distribution of y bar? Well, y bar, if h0 is true, bounces around 10, and has variance of 12 squared over 16. Let's draw a picture. Here's y bar. It bounces around 10, and we want to know what is the probability that it's going to land 8 or lower. Let's do a z-trick on y bar. That's the probability that z is less than 8 minus 10 over square root of this thing, which is 12 divided by 4. And so that gives us the probability that z is less than minus 2 over 3, or probability that z is less than minus 0.66. And when we look that up in tables, we find 0.2546.